So now we're going to have another example. So here are our vectors. So vector A is 6.01 meters at the direction of 32 degrees south of west. Vector B is 4.68 meters, 27 degrees north of east. Then vector C should be equal sign because this is an equation. Then vector C is 5.23 meters, the direction of 41 degrees south of east. Okay, so what we're going to do first is transform them to the angle which is from the Cartesian plane coordinate system. That means not using the cardinal directions. Alright, so for vector A, let's have this. Okay, so we're not going to plot the magnitude yet. We just to have a true sense of the direction. So for vector A, so I'm going to draw a Cartesian plane. So 32 degrees south of west, so we're going to start from west. Okay, so this is our west going to the south. Okay, so in this direction. Alright, so 32 degrees, so that's a smaller opening. Okay, so somewhere here. Alright, so that's the direction of our vector A. So that means you're coming from 180 degrees, okay, going to 270. So that's an increase, which means you're going to add. So the angle for vector A is angle of vector A is 180 plus what's that, 32, which is equal to 212, correct? Alright, so 212 degrees. So this would be our new angle. Alright, so for vector B, let's change markers. So for vector B, that's 27 degrees north of east. So north of east, so this is the easiest direction. So you have east here and north here. Okay, so going to this direction. Okay, always remember you're going to start at the latter direction, then the turn of the angle is to the former direction. So in this case, coming from the east going to the north. So 27 degrees, again smaller, so somewhere here. Okay, so again this is 0, right, going to 90, so that means an increase. Alright, so this is our vector B. So that means the angle of vector B is equal to 0 plus 27, which is 27 degrees. Okay, then so this will be our new angle. Right, always remember that. So for the third one, this is just 90. Okay, then for vector C, okay, let's use that. Okay, for vector C, that's south of east. So this is east, then this is south. So coming from this direction, going to this direction, okay? So what's the angle? 41 degrees. Okay, so 41 degrees going to the south, so somewhere here. Okay, so the opening is slightly bigger because it's closer to 45 degrees already. Correct? There. So for angle C, I mean angle of vector C, so you're coming from, in this case, this is 270. Then since we don't want to have negative angle, so instead we're going to utilize 360 instead. So that would be a decrease, right? So that means 360 minus, what's the angle? 41. Okay, so that means our answer is 319. Okay, so this will be our new angle. Okay, so if you're going to plot the table, it would be easier. So this would be the new angles that we're going to utilize, and you're going to notice we don't need to look after the direction because we already have the true angles. Okay, so let's try to do that. So we have x component here, vectors. Okay. Oops, let's place that a little bit higher because okay, so then we have x component, then the y component. Right, so let's do first x component. So for vector A, we have, so that's a cosine theta. Alright, okay, so that is equal to, what's our A? 6.01 meters times cosine, what's the angle? 212. Alright, so that means our A cosine theta is equal to, so 6.01 times cosine 212. So here it is, 5.0968, negative 5.0968. And if you're going to check, it would make sense since our vector is on the negative y-axis, correct? Alright, so let's set that aside. For vector B, we have B cosine theta, which is equal to, what's our B? 4.68 times cosine 27. Alright, so that would be the cosine theta is equal to, so I'm going to do the cosine first this time. Alright, so you can have a grasp of the different ways of how to solve it. So this would be 4.68 times cosine 27. So that's 4.1699. What's the answer? You see it? 4.1699. So this is in meters. Okay. vector C, this is C cosine theta, which is 5.23 meters times, what's the angle? Cosine 319, which is here. Okay, so our C cosine theta is 5.23 times cosine 319. There, so as you can see, here's the answer: 3.9471. 3.9471 meters. Then this is our R. Okay, so we'll put that aside for later. So this is R sub X. So for our A sub Y, by the way, these are A sub X, B sub X, and C sub X. Okay, don't forget. Okay, so for A sub Y, we have A sine, correct? A sine theta. Okay, which is, so basically this is the same as the one we have here, so that's sine 212. Okay, so what's the answer for this? That's 6.01 sine 212. So here, 3 point, can you see that? 1848 negative 3.1848, which makes sense because again, it's on the south or the third quadrant, so the X and the Y are both negative, right? Okay, next we have B sine theta, which is 4.68 meters sine 27. So that's B sine theta is equal to, what's that? 4.68 sine 27. Here, that's 2.1247, right? 2.1247. Then for C sine theta, so that's 5.23 meters sine 319. Okay, so this is the angle that you're going to use. So C sine theta, this is capital, is equal to 5.23 sine 319. Okay, so what's the answer? Negative 3.4312. Okay, so for R sub X, you're just going to add A sub X plus B sub X plus C sub X, which means the sum of these three. Then for R sub Y, you're just going to have A sub Y plus B sub Y plus C sub Y. Okay, so let's do that. The negative 5.0968 plus 4.1699 plus 3.9471. You can check for the signs if you think they're correct. So this is negative, so it's on the west, correct? So this one is positive, it's on the east, which is correct again. Then this is positive, which is on the east again, so that's correct. Right, so here's the answer. You see it? 3.0202. So that's our R sub X. 3.0202 meters. Alright, Alright, so this is what we need for the r sub x. Okay, so for the r sub y, let's add that. So negative 3.1848 plus 2.1247 plus, so this has a negative sign, 3.4312. So here's the answer, negative 4.4913. Can you see it? Negative 4.4913 meters. There. So take a good look. Okay, so if these are the given, alright, I'm going to erase it and we're going to do the proper GRESA. Alright, so copy this and we'll continue. Alright, so I already wrote the given required, the equation that we're going to need. So after finishing the table and all that, we'll come up with it will all boil down to having the Pythagorean theorem and this is tangent inverse, the trigonometric function or arctan. Some of your teachers read it as arctan, so that's tangent inverse ry over rx. Alright. So here are the result from the table that we have. So let's solve first for the magnitude. So vector r is 3.0202 meters v squared plus negative 4.4913 meters v squared, and we're going to place that inside parentheses. Right? So if possible, kindly show the square of these two. Some of you might not have cycle with natural display, so it would be better if you can show this. So let's first do that. So 3.0202 b squared is 9.1216 meters squared. Okay, then this one is negative 4.4913 b squared. So that's, can you see it? Negative 20.1718. Negative 20.1718 meters squared. Okay, so we're going to add them. So that's what's the sum? So that would be 9.1216. Okay, so here. Oh, by the way, I think this would be gone because of course it's squared. Alright, so after all, we're actually obtaining the distance. If you square the negative, it would be positive, right? So you should place it inside the parentheses. So that's the proper way of doing it. 4913 to be squared like this. Okay, so you'll yield the positive answer. So this is the correct one. So that would be, so here, so plus 9.1216. Okay, so here's your answer, 29.29. In this case, you can now round it off to the nearest hundredths or 2 decimal places after the decimal point. Okay, so that's 29.29 meters. Okay. Squared. But of course, we're not done yet, so let's include 2 more decimal places. Sorry. Okay, then finally, so find the square root. Okay. So that would be square root of answer. There, so that's 5.41. So there's your final answer. So cancel the square root. So that's 5.41 meters. Alright, so this is our magnitude. For our direction, we have theta is arctan or tangent inverse r sub y over r sub x. So that's let's rewrite this first so you can see there. So this would be arctan, what's our r sub y? Negative 4.4913 meters divided by 3.0202 meters. So cancel the meters because of course the unit of theta is in degrees. Okay, so let's put that on our cycle. So that's tangent inverse for arctan, negative 4.4913 over 3.0202. There. So here's the answer. Okay. So the angle is negative 56.08. So what you can do with that, if you have a negative answer, is you're going to subtract it to 360. So that would become 360 minus 56.08. So our angle is 303.92. There. So this would be your angle. Okay, so if you want to stick with negative 56.08, you can change it to something like this. So the reference of this is always the positive x-axis. Okay, so what you can do is rewrite it as 56.08. So that's coming from the east going to the south. Okay, so that's south of east. So this is also correct. Okay, but if you're going to stick with this notation of angles, this would be okay. Alright, so I hope you got those 2 ways of solving